And now section 4, you can follow along on page 517. Section 4, the problems are the same. We're still factoring trinomials, but this time there is a coefficient in front of that quadratic term, in front of your squared term. So here we multiply the squared term coefficient times the constant. So 25 times 4 gives me 100. I need factors of 100 that add or subtract to be 20. So 25 and 4, 10 and 10. Oh, 10 and 10. 10 plus 10 is 20. And I break that apart. All I'm doing is saying now 10R plus 10R, which is the same thing as 20R, but I want to break it up. Once I break it up, I can group there, group there. Now that I group, I can pull out a common factor. Both of these can be divided by 5R. If I do that, all that's left, I take out 5R, 5R plus 2. Over here, I'm taking out a 2, and I get 5R plus 2. I write down my parentheses, that's the same, and then write down anything that's extra right there, 5R plus 2. That's your answer, 5R plus 2, 5R plus 2. Number 47, we do the same thing, except for it's equal to 0. So I need to multiply 2 times negative 20 to get negative 40. I need factors of negative 40 that add or subtract to be negative 3. Well, I know 1 and 40, 2 and 20, 5 and 8. Oh, 5 and 8. Perfect. So I say, instead of saying negative 3R, I break it up to be negative 8R plus 5R. Because negative 8R plus 5R give me negative 3R. Group, pull out factors of both. For that first parentheses, I'm pulling out 2R. That gives me R minus 4. For that second one, I'm just pulling out a 5. And that gives me R minus 4. And I'll step back and I say, oh, same parentheses. R minus 4, 2R plus 5. Then I said it's equal to 0. So I said each parenthesis equal to 0 and solve for R. The biggest thing with that is make sure if it's R minus 4, you have to add 4 to both sides. So you'll get a positive 4. 2R plus 5, subtract 5, divide by 2 to get negative 5 over 2. Your solution set is 4 plus negative 5 over 2. Section 5. Oh, wrong section. Right here. Section 5 is perfect squares. They both, difference of perfect squares. They both have to be perfect squares, and they have to be subtracted. That's a perfect square. That's a perfect square. I write it as b plus 4, b minus 4. And if it's equal to 0, sorry, my lens is getting crazy. Let's see if I can. If it's equal to 0, like this one, I say b plus 4 equals 0, and b minus 4 equals 0. So my solution set would be 4 and negative 4. Here's another problem like that. Here we have 1/4 n squared minus 9/6 r squared. It's subtraction. I know I can do it. And I need to take the square root of this number and the square root of that. And I get 1/2 n minus 3/4 r, 1/2 n plus 3/4 r. Remember, I'm just subtracting the numbers, adding them. Take the square root, take the square root. Number on 56, I need to ask myself the 3 questions. Is the first a perfect square? Yes. Is the second a perfect square? Yes. This is the square root of a squared equals a. The square root of 81 equals 9. Is this 2 times a times 9? 2 times a is 2a times 9 is 18a. So then yes. So then all I need to write is a, the square root of the first term, plus the square root of the last term, squared. Solution, done. Number 58, we need to make sure that this is a square root, this is a square, perfect square. Square root of 4 is 2. Square root of 49 is 7. Square root of r squared is r. Remember, we have a square root of a constant number that can be positive or negative. So I need to multiply 2 times 7 times r. 2 times 2 is 4. 4 times 7 is 28. 28r. Yes, that equals this middle term. So then, because it's negative, both my parentheses are going to be negative. Take the square root of the first one, 2 minus 7r squared. Done. That's it. I hope you have a good day. God bless. Bye.